Hello everyone, and welcome to this lesson on sorting and searching algorithms. In this lesson, we will learn about bubble sort, merge sort, linear search, binary search, and algorithm efficiency. These algorithms are very important in computer science because they help computers organize and find data quickly. By the end of this lesson, you will understand how these algorithms work step by step using simple examples. Sorting means arranging data into a specific order. For example, data can be arranged alphabetically, from smallest to largest, or from highest score to lowest score. We use sorting in many real-world systems, such as dictionaries, phone contacts, YouTube videos, and football league tables. Sorting makes searching much faster and more efficient because the data becomes organized. Without sorting, finding information in large lists would take much longer. A sorting algorithm is a step-by-step method used to arrange data into order. Ascending order means arranging values from smallest to largest. Descending order means arranging values from largest to smallest. For example, the unsorted list 4, 2, 6, 1, 3 can be sorted into 1, 2, 3, 4, 6. Sorting algorithms are used by computers to organize data efficiently. Bubble sort is one of the simplest sorting algorithms. It works by comparing neighboring items in a list, just like bubbles rising in water. That is why it is called bubble sort. Let's look at the first pass of bubble sort. We begin with the list 4, 2, 6, 1, 3. First, 4 is compared with 2. Because 4 is greater than 2, they swap places. Next, 6 is compared with 1. Again, they are swapped. Then 6 is compared with 3, and they swap as well. At the end of the first pass, the largest number has moved to the end of the list. The current list is 2, 4, 1, 3, 6. 4 is compared with 1, and they swap. Then 4 is compared with 3, and they swap again. The list becomes more organized after every pass. Bubble sort continues repeating these comparisons until the list is completely sorted. The final sorted list becomes 1, 2, 3, 4, 6. No more swaps are needed, so the sorting process is complete. Let's summarize the bubble sort steps. First, start at the beginning of the list. Compare neighboring items. Swap them if they are in the wrong order. Move forward through the list. Repeat the process until no swaps happen. Bubble sort uses iteration, which means looping repeatedly. Bubble sort has some advantages and disadvantages. Its advantages are that it is easy to understand, easy to code, and suitable for small lists. However, bubble sort becomes very slow for large lists because it requires many comparisons and swaps. This makes it inefficient for handling large amounts of data. Merge sort is a much faster sorting algorithm. First, the list is divided into smaller parts. Then, those parts are divided again and again until each list contains only one item. Finally, the small lists are merged back together in the correct order. Merge sort is much more efficient than bubble sort for large lists. Let's see how merge sort works. We begin with the list 8, 4, 2, 6, 1, 3, 5, 7. The list is split into two smaller lists. Then each smaller list is split again. This process continues until we reach very small lists. In this step, the lists continue splitting into single items. Single items are already sorted because they contain only one value. This repeated splitting process is called recursion. Recursion means repeating the same process again and again on smaller parts of a problem. Now, the small lists begin merging back together. 8 and 4 become 4 and 8. 2 and 6 become 2 and 6. 1 and 3 become 1 and 3. 5 and 7 become 5 and 7. The algorithm combines smaller sorted lists into larger sorted lists. Finally, the sorted sections are merged again. The algorithm compares values carefully and places them into the correct order. The final sorted list becomes 1, 2, 3, 4, 5, 6, 7, 8. Merge sort is very efficient for handling large lists of data. Let's compare bubble sort and merge sort. Bubble sort is simple and easy to understand, but it is slow and mainly useful for small lists. Merge sort is faster and more efficient, especially for large lists, but it is more complex. In most real-world systems, merge sort is the better choice for large amounts of data. A searching algorithm is used to find specific data inside a list or database. Examples include Google searches, finding contacts in a phone, searching exam results, and finding YouTube videos. Searching is one of the most common tasks in computing. Efficient searching algorithms help computers find information quickly. Linear search is one of the simplest searching algorithms. It checks items one by one from the beginning of the list. For example, if we want to find the number 13, the algorithm checks 3, then 7, then 9, and finally 13. Linear search is easy to understand, but it can become slow for large lists. Here are the steps of linear search. Start at the first item. Compare it with the target value. If the item is found, stop searching. If not, move to the next item. Repeat the process until the item is found or the list ends. Binary search is much faster than linear search. It works by checking the middle item first. The list must already be sorted before binary search can be used. If the target value is smaller than the middle value, the search continues in the left half. If the target is larger, the search continues in the right half. Each step removes half of the remaining list. Let's look at a binary search example. We want to find the number 13 in a sorted list. First, the algorithm checks the middle value, which is 31. Because 13 is smaller, the algorithm searches the left side. Next, it checks 24. Again, 13 is smaller, so it searches left once more. Finally, the number 13 is found. Binary search finds values very quickly because it repeatedly removes half of the list. Now let's compare linear search and binary search. Linear search is simple and does not require sorting, but it becomes slow for large lists. Binary search is very fast and efficient for large lists, but it requires the data to be sorted first. Choosing the correct algorithm depends on the situation and the type of data being processed. In computer science, we often analyze algorithms using best-case and worst-case scenarios. For linear search, the best case happens when the item is first in the list. The worst case happens when the item is last. For binary search, the best case happens when the item is already in the middle. Even in the worst case, binary search usually needs far fewer comparisons than linear search. Bubble sort uses a method called brute force. It repeatedly compares many items until the problem is solved. Merge sort and binary search use divide and conquer. They break large problems into smaller problems, solve them, and combine the results. Divide and conquer algorithms are usually much more efficient. Sorting and searching algorithms are used everywhere in modern technology. Sorting is used in online shopping systems, banking systems, and exam rankings. Searching is used in Google, YouTube, databases, and AI systems. Modern technology depends heavily on efficient algorithms to process huge amounts of data quickly. Let's summarize what we learned in this lesson. Sorting algorithms arrange data into order. Bubble sort is simple but slow. Merge sort is fast and efficient. Linear search checks items one by one. Binary search repeatedly divides lists in half. Different algorithms are suitable for different situations. Algorithms help computers process huge amounts of data quickly and efficiently. Thank you for watching this lesson on sorting and searching algorithms.